Alkanes, an Introduction. The purpose of this video is to introduce the first several members of the alkane family. Like all other hydrocarbons, the alkanes are produced from crude oil and gas, either by drilling in the ground or in the seabed from rigs such as the one shown in the title page. They all follow the formula CnH2n+2. That is, the number of hydrogen atoms per carbon atom is always double the carbon atoms plus 2. The first member in the series is methane. Here is its molecular formula and its structural formula. The next member in the series is ethane. Molecular formula, structural formula. As we continue in the series, you can see how the structural formula soon becomes unwieldy. A third type, called the condensed formula, is a good compromise. For methane, it is the same as the molecular formula. Ethane is this. You can now see how the molecular formula may be the shortest, but it shows only the ratio of atoms in the molecule, so is not as informative as to the structure. The structural formula shows all bonds and all connections between atoms, and is therefore the most informative. The condensed formula is in between by being more compact than the structural formula, yet showing something of the structure. You can see how the CH3 group has been created like this, and for propane, the middle part CH2 formed like this. Here are butane and pentane. You need to remember the following for the first four members. The prefix meth implies one carbon. Any compound with the word meth in it implies one carbon atom in that molecule. Eth implies two carbons, prop implies three carbons, and but 4. After that, the Greek alphabet takes over with pent, meaning 5. We'll see more in a moment. Do not mix up prop and pent. Prop for 3 carbons, pent for 5. These first 4 prefixes will just have to be remembered. With practice, this will come naturally. Here are the rest that we'll look at. You can see the Greek prefixes: hexa for 6, hepta 7, octa 8, nona 9, and deca 10. I'll do the last 3 in a bit. Now, even the condensed formulas can become quite unwieldy, so the middle CH2 groups can be grouped in brackets like this. The total number of carbons doesn't change. Dodecane has 12 carbons, octadecane 18 carbons, and triacontane 30. Finally, I want to point out certain alkanes that are commonly found in everyday life. I'll also point out one physical property, boiling point, for comparison. Methane boils at minus 162 degrees Celsius, so it's a gas at room temperature. It is known as natural gas, which can be used in heating homes, as well as stoves that work on natural gas. If its temperature is lowered to about minus 160 degrees and under some pressure, it becomes a liquid and can then be transported through pipelines. This is one example where it's above ground. In most cases, attempts are made to keep them underground. The liquid natural gas through these pipelines is known as liquefied natural gas, or LNG. Notice that as the molar mass increases, so too does the boiling point. Propane is probably best known as the gas used for barbecuing. It comes in tanks like these and is in liquid form. Its boiling point of minus 42 degrees Celsius shows that it is a gas at room temperature. But when put under pressure, it will liquefy at room temperature and so can be stored in these tanks. In the same way, it is used in propane torches for soldering copper pipes or low-temperature welding. Butane, in lighter fluids, boils at 0 degrees, so again, a gas at room temperature. But its higher boiling point makes it easier to liquefy under pressure, which is why lighters like these are strong enough to keep butane in liquid form. These butane torches give a very strong flame, and of course there's the very common barbecue lighter. Here are the remaining boiling points. Dodecane melts at 10 degrees, so it's a liquid at room temperature. It represents molecules with 10 to 18 carbon atoms, which are kerosenes and jet fuels. Octadecane represents molecules with carbon chains of 18 to 25 carbons and are the basis of lubricants. Similarly, carbons 20 to 30 are found in paraffins, like candles. This ends the introduction to the alkane series.